Alright, so today we're going to look at a chemical reaction, what happens when you run out of something. And of course, when you run out of something in a chemical reaction, it stops. So this is called a limiting reactant product, and the reactant that you run out of is called the limiting reactant. Because when you run out of it, it limits how much of the product you can make. So let's look at this reaction. If you have one robot head plus one body, two legs, and two arms, you can make one robot. So, if we add 23 heads, 12 bodies, 23 legs, and 34 arms, how many robots could we make? So let's look at this individually. So the way we're going to solve this with robots first is think of each of these as a reactant, and we're going to look at how much product we can make with each of our reactants. So with 23 heads, we could make 23 robots. With 12 bodies, we could make 12 robots. With 23 legs, now it takes 2 legs per robot, so for that, we could only make 11 robots. And then with 34 arms, we could make 17 robots. So if you look at this, the legs are going to limit how many robots we can make. We only have enough legs to make 11 robots. So after that, we stop making robots. So our limiting reactant in this case are legs. And so we're going to solve our limiting reactant problems the same way. So the first thing you need to do is you need to recognize that it is a limiting reactant problem. So if it gives you amounts for more than one reactant, it's going to be limiting reactant. Second thing, pick one of the reactants, it doesn't matter what you start with, and use stoichiometry to figure out how much of one of the products you could make if you use this reactant up. Make sure you read the whole question, because if you're asked about a specific product, you want to make sure you use that. Then you do the same thing for all the other reactants. And the reactant that can make the least amount of product gets used up first, so it's the limiting reactant. And then you can read the rest of this. This is in your notes. So let's look at an example. So let's say you had 16 coppers plus 1 mole of sulfur produces 8 copper 1 sulfates. So here's our problem. If we had 100.5 grams of copper and 235 grams of sulfur, how much copper sulfide would we make? So this is different from other problems we've had so far because this gives us two amounts. We have 100.5 grams of copper, we have 235 grams of sulfur. So you got to recognize this is a limiting reactant problem. So we can pick either one of these and we want to figure out how many grams of copper sulfide we can make. So let's start with 100.5 grams of copper. And this is our normal gram to gram problem that we've been doing. So we're going to set this up to do that. So in 1 mole of copper, there's 63.55 grams of copper. For every 16 moles of copper, we have 8 moles of copper sulfide. And then in 1 mole of copper sulfide, there's 159.17 grams of copper sulfide. So we can make 125 grams of copper sulfide if all the copper reacts. Now, we'll do the same thing for sulfur. 235 grams of sulfur, there should be a subscript, sorry about that. In 1 mole of sulfur, there's 256.6 grams. For every 1 mole of sulfur, we are going to produce 8 moles of copper sulfide. Once again, we use the same molar mass. So 1 mole of copper sulfide, there's 159.17 grams. So multiply the top, divide by the product at the bottom, and we get 1,166 grams of copper sulfide. And if you look at this, all right, what's the smallest amount of product? It's 125 grams of copper sulfide. So we will make 125 grams of copper sulfide, and then we're going to run out of copper. So we have enough sulfur to make over 1,000 grams, but once we run out of copper, it doesn't matter how much sulfur we have. So we're going to make 125 grams of copper sulfide, and copper is our limiting